20 minutes. Whew, damn.
It's there.
Yay.
Yep. I see you.
Okay, so let's do this. Let's drop off the Teams and go over to there, and just I'm going to leave the Teams. You can just chat with me in terms of how the sound is and everything. Okay. On Teams.
Got it. I was going to mute both of us, and then yeah, I'll just type in the chat.
Yeah, just use the chat or use the Teams chat if you need to. All right, I'm going to close the call. Hopefully the audio is working here on YouTube. Cool, and how's the sound? Actually, I guess you could always type in to YouTube on there. Let me actually go over to YouTube as well. You hear my keyboard? Can you hear me talking? Trying to decide how bad the delay is based on what you type. Nice. Okay. Boom, there we go. All right, so we're going to start in about 2 minutes. Hey everyone, welcome. Thank you, thank you. We're going to start in about 1 minute. So this is Mark. I'll be doing the presentation today. We're going to only go for about 30, maybe 40 minutes, I think is how long this one's going to last. based on the material we have today and any questions you have, we can go as long as I can stand for about 45 minutes. I think Dan has to drop at the bottom of the hour, so Dan will be on the chat today. I will be doing the presenting today. And this is Mark. I'll try to jump over to the Q&A as much as I can as well, to the chat. Put any questions or any comments at all on Data Factory in the chats. If we don't get to them today, we will archive that and come back and post any follow-ups we need to, either on the follow-up, the next session we have, next live stream we have, or we can use our blog. Let's do that under Microsoft Tech Communities. Maybe I should have added that link in there. We could always do that later too. All right, I think we'll get started. We're about a little bit after the hour, so I think we're probably good to get started here. And then, of course, we'll put the video up on our site as well, so you can go back and review this. The topic today is going to be inline data sets and 4 new formats that we've brought to markets. That's XML, Excel, CDM, and Delta. And what I want to do before I talk about those formats specifically is I want to talk to you a little bit about what an inline data set is. It's a new concept that we've introduced, and it's only available in data flows. And the reason for that is because data flows being the newer technology with a new feature within Data Factory, whereas copy and lookup and get metadata and all the other sort of activities have been there for quite some time. The difference being that data flows, as opposed to those other activities, data flows is meant to provide very deep and rich understanding of your data and of your sources and sinks in order to be able to do things like transform that data and to be able to map it in very complex ways, build rules for mappings. For example, to be able to have conditional splits and joins, and to be able to aggregate that data. So there's a different level of understanding that sometimes we needed to have, we found in practice, of that data. And so what we did was we introduced the concept of inline data sets. So data sets have been a top level entity within Data Factory for quite some time over here, really since the beginning of ADF, since V1. And I have a whole bunch of data sets. I have, how many do I have in my factory? This factory has 280 data sets. So what you can do with an inline data set is you can add that as a source or a sink, and that goes as a definition of that data set directly in your source or sink in data flow without needing to define it as a shared data set. These data sets are shareable, usable through any aspect of or any artifact within my factory that can use data sets, which is great. But if I'm doing something just for the purpose of data flow and I don't need that rich understanding of my data to be able to use it in other areas of Data Factory, then you can just define it directly in your data flow. So here in this data flow, let me show you what I mean by this. So let's add a new source, this source 2 over here. And at the bottom, we introduce this new idea here of source type. Then we defaulted it to data set, which means that by default, when you make a data flow, you add a source. And every data flow needs a source, so you always start with a source. The default type is data set, which means it's going to be a shared data set. So it never changed anything that you've already built. We didn't, it's completely backward compatible. There was no changes to what you've done before. But what you can do now is when you pull that down is you can say, instead of a shared data set, I want to use an inline type. So there are the 4 types that we're going to talk about today. They all show up in there. We're going to be adding more and more to this. Some of these, by the way, are only available as inline types. CDM and Delta are 2 examples of that. And that is because those are only used today in data flow. They're not available to you in the other areas of Data Factory because they're meant for working with ETL specifically and with data transformations. And so what that means is that instead of exposing it to you as a data set that we felt like it sort of would be a little confusing in terms of why do I see this data set but I can't use it in copy or something else, we just exposed it here as an inline within the source and sink of data flow. So what you'll see is this also indicates to you directly and very quickly which types are available as sources and which ones are available as sinks, so that when I go to my sink and I select an inline, I'm only going to see those 2 because we don't write to XML or Xlsx. In fact, we don't do that in copy either. Those are read-only source types at this time. So based on your feedback, we can always make those syncs later, but that's just the way that we took it to market in the first cut of those data sets. So let's go back to the source. Now, when I select an inline type instead of a shared data set, actually, let me go back and do that. When I have this defaulted data set, I'm going to see the whole list of the shared data sets, which is the same as the list over here. Difference being that we show the icons for the type of data set that it is, so you can quickly see the type of data set that you're using. If I select one of the inline types up here, so let's say I wanted my source to be an XML file. I select XML, and this switches down here from asking me about a data set to a link service, because now I just need to tell Data Factory, okay, for this data flow, I'm going to use XML directly inline to my source. It's not going to be a shared data set. And then I'll be able to say that I want it to be from this link service. So that link service is going to be my blob store. Now what's going to happen is the source options are going to change for every type of inline data set that you choose. So in this case, I chose XML as my inline source type. So now I get all of the prompts I would get from a data set for my XML. So now we give you the opportunity to define what that's going to look like for XML. So in this case, I'll just point to an XML file under my samples, my sample data, XML. And let's use the customers.xml. Okay. And I think that's pretty much all I need, but I will have the other options within the source options here that you would typically see under a data set. It's just put under here. And all the rest of the functionality from a data flow is still existent in here as well. Like they delete the source files, move the source files when I'm done with my data flow, and all those sorts of things. Pick up just a certain time frame when the file was last modified. That's all there as well. So then what happens is under projection, now the projections can be a little bit different because I am not, in this case, picking up a data set that already has a schema in it. So this is an inline data set, which means that there is no schema yet associated with it. If I want to store the schema in my source, I can do that, but I have to use the projection tab and say import schema, and then I'll get the projection from that source. So in this case, I'm bringing in an XML, so it's a complex hierarchy of data because it is XML, so it has hierarchical data structures to it. So you can see as I get down to the leaf level, I can see that I have a customer ID, a company name, contact name, contact title, so on and so forth. I have a better example of this one later, so I'm just going to save that for that, just to show you that. And by the way, I'll show you this in the other example and demo, but you can change the essentially what is the URI. You have the option, the source options with XML, to change that and to give that a name. So I can say, for example, I want to change that URL from AdventureWorks to AW or something like that. And I'll show you how that works in just a bit. Let me actually take that out. Okay. So now in the sync, this will now let me do something like convert that XML into, let's say, JSON, and or to be able to transform it and flatten it out into something that can go into relational data store. So I can do a hierarchical to relational here in Dataflow as well. But I'm not bound now in my sync to also use an inline data set. I could use a shared data set at this point. These things are not connected in any way. So however I'm accessing the source data does not drive how I access my destination data. So in this case, I could say I want to put this into a shared data set that is a JSON type. So maybe just a JSON folder, and that would be certainly fine to just do that. Just do auto mapping on it and go ahead and store it. This is all you would need to do to take your XML and store that into JSON. But if you want to do, let me actually take these off of my design surface. That's how you will access inline. What happens then is you can use those different data sets in different ways. For XML and Xlsx, you don't need to use inline. They can also live as data sets. So here's an example of my, where do I have it over here? Let's take a look at an example of a table. We'll go to this XML data flow here. So we'll stick with XML for a second. So in this source, I'm again using the inline, but I could use an actual data set. So I should have a data set over here for XML. Yep, there we go. So there's XML customers. So I could always define a data set. Now, if I define a data set here within my factory, this XML customers one can now be used by other activities such as a copy activity. So in my pipeline, when I go to add in a copy activity in here, I'll be able to define that as one of my sources in here. If I were to have chosen XML as an inline data set type within my data flow, then I wouldn't be able to see it over here because it wouldn't be a shared data set. So hopefully that gets across the idea of what we've done with inline data sets and what they mean. And now we can talk a little bit about some of the details of using those. So let's go back into XML. So this data flow here in end-to-end shows you some of the flattening that you can do, some of the renaming you can do within namespaces within your XML. So I have that same file that I was pointing to earlier. I'm pointing to the customers.xml. And here I've defined the to map the URL to AW as a prefix I'm using. So when I look at the projection, I'm now going to get a little bit nicer looking projection now that I have the root level. And then I have I have customers, which is a complex type that has a customer array with the different attributes, different properties of a customer, their ID, name, contacts, name, fax, has a fax number. Well, it is XML, so I think we should have older sort of things in there. We should have, like a 7-digit phone number and those kinds of things. Anyway, so that's all. That's how we read XML. And then what happens is, I just go over to a data preview just to kind of show you what the data looks like. This, of course, won't matter whether you're using inline or not. Everything else is going to act exactly the same. So one of the principles or the primary concepts of data flow is get your data into the sources, as many sources as you'd like to within your data flow, and then we treat that as data from that point on. It does not matter what type of sources you're using. You can join data from all kinds of different sources, so you can essentially you can create lakes of data with data flow that could be from XML plus Delta plus CDM, SQL, all those different sources can come together into a single data stream, and you can join those together in interesting ways. It doesn't matter. We end up putting all that data in memory in data frames in Spark behind the scenes. And so what I'm in right now is the Data Factory UI. And so when you're in Data Factory, the Spark engine for data flow behind the scenes is Databricks. But when I'm over here in Synapse, and my debug session expires, I'll just restart it here on my Synapse. This is Synapse Analytics, and Dataflow is surfaced the exact same way, except for that the backend engine in this case is going to be using Synapse Spark with it. So the Spark engine is going to be the driving engine behind your data flows in either case. It's just that depending on which platform you're in, it's the different engine that runs those data flows. But the concept is the same, where that data is going to look just like data from this point on. After my source has been defined and I tell Data Factory all about that source, I don't have to go in to write the Python code to connect into any of that data. I just give it the data set information. We now treat it as data frames from that point on. So now what I can do is I could flatten the customer hierarchy from here, and I can flatten the orders. So within this data, there were two different, if I go back to my source data preview, you'll see two different complex types. There's customers and orders are within this single root property within my XML. So the first thing I do is flatten the customer. So I use the flattened transformation. You'll see the flatten over here on the, we have it right there under schema modifier. And then for flatten, all I do is I just tell Data Factory what is the array that I wish to flatten. So in this case, I'm picking the customers array, which is right here. Everything else is grayed out because they're not arrays, they can't be unrolled. So you flatten at that level, and then you can define what they look like on the right hand side. So I made these lots, I simplified these from the complex sort of dot notation to just single values. So the flatten is kind of like an action of taking your hierarchy, flattening that out to relational, but also giving you the ability to use sort of that select transformation capability of Dataflow to also be able to rename and alias those columns in there as well, or to take things out. You can do that here as well. So then I chose the order hierarchy to flatten out, and then what I do is I clean the addresses. So this is a way that you can do transformation of data, even if it is all within XML. It does not matter. So the way that I was able to do that is I have to define that hierarchy within the transformation, and you don't have to type all this out. We have a shortcut for this that's actually available to you from the input schema. So I just realized that my stream is invalid on this one. I gotta figure out why that is. Give me 1 second. So if I reset this, it's not coming out the way I want it to. So AW orders right here, and then let me actually take out this second flatten here, and we'll just do a clean address off of that. So if I go in here and I look at my input schema, give me 1 second. Let me see why I'm not getting this the way I want it to. So I'm going to go to inspect on this. I'm going to see what my output is. I'm not getting any output at all. Okay, got it. So here's my input schema, and it looks like there is something invalid in this flatten. So the output is blank in my inspect, and that's how I can tell that. So if I go over into my flatten, let's do this. Let's do a data preview and see what we get. This might tell us. Aha, got it. Okay, so it's all right here within this flatten. So let me do a reset on my mapping down here. I'm going to add something invalid in my mapping. Okay, that seems fine. Now I'm going to look at the inspect so I can see my metadata, and now I have a cleaner output from my flattened customers. So now in clean addresses, when I go in here, I didn't need to type out this full hierarchy syntax. If you just go to the input schema, you will see this shortcut we have here. This will actually enter that entire hierarchy syntax for you. And all I did was a replace. So what I'm doing is I'm replacing BLVD period with spelled out boulevard in my data. So I'm able to address a specific, in this case, address property within a complex type within my XML and be able to clean it and do some data cleansing on it without needing to get too complex with it. Essentially, the transformations that you typically use within your data flows all come into play and work just fine here in this case. And so if I look at the address, you'll see that BLVD has been transformed into Boulevard. So it was just a couple of steps to do that, and then I use a select over here just to kind of clean up the output data a little bit. I didn't want fax there because I don't care about fax machines, so I took out the fax column with a select, and then I sync that into JSON as my output. So that's an example of using XML. This is XML as an inline data set type, and then JSON as a shared data set type output. All right, now let me quick go over here, see how we're doing. Dan, are you able to keep up okay here? I didn't know if you needed some help on the chat here. I might just continue with this and come back to the chat in a couple of minutes because I want to go over the other data set types here as well. So that was XML. That's the inline data set type. Let's talk a little bit about Delta. Delta's a little bit more involved, so I'm going to spend a few minutes on that. And I just realized I'm probably going to blow through that 30-minute promise I had at the beginning. It's probably going to go closer to 45 minutes. Dan, if you have to drop at the bottom of the hour, I think that's fine. And yes, I did get the inquiry about CDM. We'll do CDM before we go as well, real quickly. So Delta is the new dataset type that allows you to create Delta lakes within your ADLS Gen 2 and to also be able to manage that as if it were a sort of a database type. You can do alter rows on it, you can do updates, inserts, full set of transformation on it. So we have a video out there already for this, but I'll just walk you through the transformations and data flows that I use to be able to do this. What I did first was this step right here, a very simple data flow that just creates a Delta lake. So you'll see my sink is that same type that I just talked about earlier of a data set called an inline. So you have to select Delta for your inline type, select the location of your data lake. My link service points to my data lake with my credentials in it. And then all I do is tell data factory where I want to put my folder for my Delta Lake. So over here on my Storage Explorer, I think I have to click here to show you my Storage Explorer. Give me a second. So I'm not too good at the software yet, so bear with me. There you go. You should see my Storage Explorer now. So under my container, I created that called, what did I call it again? I called it Delta 1. So what that'll do is when you run this is it'll create a folder in here. Sorry, that's my blob. Let me go over to my data lake. I believe it is this one here. Let me go and find it. So to find which data lake I'm using, I'm going to go to my sync settings. I'm going to go to the link service, click open, and it is MAK ADLS Gen 2 East. Yep, that's the one. So that is this one over here, and if I go to my containers, my container, and there it is. So Data Factory will create the folder for you. You don't need to worry about setting up your Delta Lake. Just point to where you want it to go, and it'll create the Parquet files and the log files and everything else that needs to manage that Delta Lake environment. Okay, so let me close my Explorer. Now back to the browser. All right, so now this is all you need to do to get started with a Delta Lake is just have your source data. This is my movies data. This is just a regular CSV shared data set. I'm not doing any transformation. I'm just saying take this file as is and or take this source data as is and create a data lake for me, a Delta Lake for me. So this will create the Delta Lake. I'm not doing anything special in terms of the mapping. This is just auto mapping. So all those fields you see from the data preview will land into the Delta Lake as is. When you run this from a pipeline, it'll take about 45 seconds, and then you'll get, depending on the size of your data, this is about 10,000 rows, so it's not very big, but it'll create all of the Parquet files you need to define that Delta Lake in your data lake folder. You can set the partitioning per your own requirements in the sync, just like you can for other dataset types. So if you wanted to partition the data by hashing or by round robin, and if you want to set the number of partitions, my browser, by the way, has frozen on me, so bear with me for a second. There you go. You can set that in here as well. You can click set partitioning and set that on there if you like. So when you run this, you'll get the folder created, you'll get the file, the Parquet files created with this data in it. Now the next step that I do in the demo that if you watch the video you'll see is I then take that same data now that it is in the Delta Lake, and now I can work with it. So I can have a source that is a Delta source. And this allows me to do any of the other transformations I would typically do with data. It doesn't matter at that point. Again, everything is just seen by Data Factory as data within data frame within Spark, and you can transform it and you can work with it from that point on. So my source type is inline. It is Delta. All I have to do is point against that folder where my Delta Lake is, and then I can work with it. Now you can use other capabilities here that are inherent to Delta Lake. You can query, what Delta Lake does is it maintains versions of your data, so you can go back and look at older versions by timestamp or by version number on it, and you can control how long those are kept as well. In the sync, we have the ability to set the value for when those versions are vacuumed, as they call it within Delta Lake. So that is under settings, and you can set that value right here. So the retention threshold will be 30 days if you leave it as 0, or you can set the retention threshold in hours on your own that way. But you can see in this transformation I'm doing updates. So this essentially allows me to maintain maintain a set of data in Delta Lake that does updates, inserts, and deletes. And in this case, what I'm doing is I'm saying update everything because I'm saying it's true. And what I actually did here was just to add a new set of values into the existing data. And when you run this, what's going to happen is it's going to update the files within your my Storage Explorer is closed now. So now let me bring it back up. There we go. Hey, I'm getting the hang of this. It's just going to update the files within your Delta Lake. So your folder will get updated as you run updates on your data flows. So now let me turn that off. Boom. Now, once you've run a couple of these and you've updated your data in Delta Lake, what you can do is this. I have this really simple data flow here that is just a source of data. And what I did was this other data flow over here, I'm going to show you this one real quick because I have a alter row on it with a delete policy of delete any movie that was released before the year 2000. And then on the sync, I just say, I again point to my Delta Lake and I say allow deletes. So that'll actually delete those files out of my Delta Lake. And you can look at the different versions of it. So if I go over to Delta Flow 3, all it is just reading from my Delta Lake. And I have all my source options. I'm going to use the versioning so you can see the different sets of data that's going to come back. So if I set this to say, let's say look at version 2 of the data, you will see different set of values come back based upon the updates that you've done to your data. So in my case, it's going to be deleting any of the movies that were released before the year 2000. So it's a very rich and useful feature that is built into Delta Lake that we surface through ADF because we've enabled this as an inline data set type. So again, this can kind of show you a little bit about the value of us allowing you to inline data sets. So you can see all the movies that were released before 2000 have now been taken off. And I was able to see the ones that were there before by going back into the source options and just setting that version to the version 0 when things were written. And you'll be able to see that all of those movies are still there. And I apologize because the live stream seems to be slowing down my browser, everything on my computer just a bit. Let me set the version, go back and refresh this. Give that a second to show you the original set of data, and then I'll do CDM next, and then we'll do quickly Xlsx before we close up this live stream. And we will be doing another live stream again next month in August, so I encourage you to give us some ideas of the things you'd like for us to demonstrate and to talk to you about next. I'd love to hear your ideas if we can get some of those topics scheduled for you. Okay, so that's Delta. Very useful in terms of managing a data lake. All right, so let's look at CDM next. So I'm going to go over here to this factory first, and of course my debug session timed out. So your debug session, just so you know, if you haven't used data flows before, your debug session will spin up in the case of ADF, a Databricks cluster in the background so that you can work with your data in your logic in real time. Our intent of having this feature is so that you can preview your data as you're building your transformations and be able to see in real time what the data looks like, to do unit testing and sort of smoke testing with that. And then you'll also be able to use that data to make sure that your transformations are correct as well. Once you've done that within your data flows, you can go into the pipeline part of Data Factory, and you can actually execute this. When you're looking at the data preview of data, so when I was over here looking at this data preview, all this is a snapshot of the data in memory at that time in the data frame. This is not writing any data. That's why I can have just a source, like in this case. But when you run a debug pipeline with the data flow, it'll actually write that data into the sink. So I'm going to wait for this to come up. I'll probably come back to it in a second, but here's how you define CDM. In this case, this is a CDM source. CDM is an inline data set type. And in this case, I'm using the model.json. So I believe this is an example that was exported out of Power BI or Power Platform or one of those. And it has an entity type of account within it. So model.json is a JSON structure, a JSON file that has that is defining entities using the CDM sort of formats, if you will, or the CDM principles for define how you define entities. And I'm telling Data Factory I want the account entity out of it. What Data Factory is able to do is able to find the model.json in this root location. So within that folder, the data/model test is a model.json that has an account entity in it. This is what this is saying. So this is saying find the account entity in there and work with it. So once I've have that as part of my source, part of my data flow, the rest of the stream again just works like data with data frames. It makes no difference that it came from CDM or model.json any longer. So when you go to your projection, because this is inline, again, you have to import the schema here. There is no data set associated with it. This is a very wide set of data that was defined here in this accounts entity, but it has the richness of the data types associated with it because that is defined in the model.json. And we can also auto-discover. Don't forget, Data Factory with data flows has the ability to infer data types. So when you import schema, you'll get that option to be able to infer data types, and you'll see that right here. So as columns come in and out of your definition, essentially what we call schema drift, you can say infer the data type of those drifted columns, and we'll be able to store the data type in your source as well. That makes it much easier to work with the data as you transform it. And then the sync is just like any other sync. So at this point, I'm taking CDM data that's coming out of model.json. Model.json, if it was exported from Power BI, will contain the data that was exported from Power BI. It will contain that data from that data flow. Will be located in partitioned files in ADLS Gen 2, and there is a pointer to that location inside the model.json. So Data Factory is able to read that data and let you work with it as a source. That's what's happening here. And the sync is just a regular sync. So in this case, I'm just syncing it to a shared data set, which is really just a folder. So the mapping for here is really just going to be auto mapping and saying, taking all of those columns and drop that into CSV. So I've taken a model.json CDM file and I have exported that, converted that into CSV in this case. When this comes up, I'll show you what the data looks like when my debug session launches over here. On this screen, I think I might have a CDM example over here of the manifest example. Let me quick see if I've got it. It's on here. Give me a sec. Oops. My browser is slowing down big time. Bear with me. There we go. Yep, here it is. So the manifest style of output is one that you're more going to see from the newer sort of CDM tools or business applications that produce CDM files. In most of the cases of anybody who's working with CDM and Data Factory today, you're probably going to have a model.json that you've exported from Dynamics or from Power Platform or whatnot. But if you have manifest, that can also be used here as a sync. So we do not sync the model.json because CDM is migrating over to the manifest style of output of a file format. So what happens is when you define CDM as a sync, you will again say inline dataset type, common data model. You will not get the option of model.json or manifest here. This has to be a manifest style. So what will happen is we need you to point us to the definition for your entities. So in this case, I'm writing transactions. So I'm saying here is the definition of my transaction. It's located in this corpus folder under the CDM folders. I think I just got this from the GitHub location, the GitHub CDM repo, where they have all the different business entities stored and defined as CDM. So what I'm going to say is here's where I want the manifest file to go, and here's the root location for all of my files. You can even set partition paths in here so you can get very advanced in terms of how you write the output data. But what this is going to do in this case is take source data, which is CSVs, against my movies data. Nothing really too fancy going on here. I'm sorry, movies and transactions. I have a bogus transaction file that I'm going to combine together through a join with my movies. And I'm joining that because, again, these are nonsensical joins. The transactions have nothing to do with movies. But I was able to do that by creating surrogate keys. So I create two different surrogate keys and use that as my primary foreign key relationship. So I'm saying wherever the transaction ID equals movie ID, join those. But what I want to demonstrate here for you is that you can take any format of data that Data Factory can accept through a data flow, and you can then write that as CDM data. So this is going to come out as a CDM manifest. Let me make sure that I'm not sure if this actually still works. Let's go ahead and refresh and see if I have this one working. This will then generate the entity files. By the way, you define the format for those entity files here. So I have this coming as comma separated. You could also choose other separators. You could choose Parquet as well. Probably Parquet would be a better format. I just left it as CSV just as the default. So it's going to write a series of files, and here's the data, what it's going to look like. There's a bogus transaction ID, and then there is some of the incoming transactions together with the other data that I wanted to bring together for my transaction entity. So notice what happens is when I map this data in the sync, I'm mapping it to well-defined entity types, or I shouldn't say entity types, well-defined column names from the entity transaction. Okay? The entity name under settings was transaction, defined in my CDM file. So what happens is, under my mapping, I will see the column names that are associated with that CDM type. And this is the entity. This is the entity called transaction, and so I'm mapping that here. Yeah, I could have chosen other mappings. This is just like regular data flow, data factory stuff here. I could have chosen store ID, or I could have chosen one of the columns from my movies if I wanted to do something silly. But you map it, you sync it, and then when it writes, it's going to write this data with the manifest and with the comma separated files. There you go. I mapped purchasing channel ID to movie name to movie title. So it's nonsensical, but it shows you how you combine data and then write to CDM. All right, I'm going to finish in 10 minutes, I promise. So let's go over to Xlsx and we'll finish up there. So the Xlsx types, did I not have one open? But I forgot to. Let's do that now. Excel. So let's open up that data set and open up this data flow here. Yeah, this is probably a good one. Okay, so I'm sorry, I did have it open actually. For Excel within Data Factory, again, this can be used in copy activity and in data flows. Data flows accepts Xlsx as both an inline and a data set type. So I have examples of that here. This is a shared data set. This is the sales Xlsx, and this one down here is an inline type of Excel. And this is pointing to my financial sample Xlsx. Let me show you a quick peek at what this data looks like in the Excel. So here's the financial data. This is coming from one of our examples online in Microsoft.com of financials, and Xlsx only has one sheet. The other one I have is the sales data, which I put together really easily and quickly, and so it's very simple. And it just has two sheets, currency sales 1 and currency sales 2. Okay. So let's go back to our Data Factory UI. Boom. And what you'll see is that let me first go to the I'll tell you what, I'll first go to the data sets. So the let's do customers. Yeah, so here with the data set type is very, very simple in terms of you just point to a XML file. That's not the right one, sorry, Xlsx over here. You just point to your Xlsx file, which is all I'm doing here, and then you tell which sheet you want. Now, we were able to discover the sheets, and the sheet name is just the one for this financial sample.xlsx. For the sales workbook, I had two sheets. So you see currency sales 1 and currency sales 2. Now in the data set type, again, this is where the finer grained understanding of data is required in data flow. Everything is read as a string, almost as if it were a CSV or a delimited text file. But inside of my data flow, I want to know a little bit more about that. And so inside of the data flow, you'll see that I'm able to, under projection, I'm able to have Data Factory detect those data types for me. And now I can see that, yeah, okay, those are actually doubles, and this is a string. When you detect data types, by the way, you can define what you want to use as the default for those numbers. These were just the default that Spark chose for me for those sales ID and amounts. Maybe I wanted those whole numbers instead to be shorts, or I wanted the fractions instead of doubles to be decimals. You can set that here in default formats, and then when we auto detect the data type, those will come up as those different types instead of double. You can define that. And then on the more advanced, the more complicated financial sample Xlsx, I did that here as an inline data set. So I get those same kind of options you saw in the data set replicated over here. Again, it has the sheet name, so I put in sheet 1 because only the one sheets on that workbook. But then under projection, oops, I didn't mean to click on that. But now under projection, I'm able to see the detailed data types instead of just string. So I can work much better with my data, and so I'm able to do things like lookups against that. Here I have a lookup of country between my sales and my finance, and when I do a data preview on that, you'll be able to see that's going to find the matches of the countries between my made-up sales workbook and the currency financial workbook. Alrighty, let me quick go back to that. So that is pretty much it for the demos. I think at this point we could probably just answer some questions. Anything else that you want to discuss within the chats? I think Dan might have dropped or had to drop off early, so I'll stay on for another 5 or 10 minutes. If you'd like to talk about anything else, here is the results of my data flow for my Xlsx. Every time I found a match on Germany, it was able to bring in the additional data coming from my my sales currency data that was related to Germany. Everything else is flowed straight through from the financial sheet because I used a lookup. Lookup is by default a left outer join, so that's why everything flows through plus the matches. Okay, I'll leave that up. I'll go over to the chat and see if there's anything I can jump in here on. Oh boy, there's lots. Okay, I'm gonna try catching up. That was all I had to demo. So if you want to jump off of that at this point, that's fine. If you want to stay on, I'll be on for another 5 minutes or so, and then I will share the video of this recording of the live stream on our Azure Data Factory YouTube channel. I know we had a session last month, I think it was, with Paul Andrew doing his metadata framework, and I think I messed up the recording on that and didn't save. So I think I learned my lesson on how not to do that or how to do that going forward. So should be able to present to save the video this time. So I'm gonna jump over to the questions here. So with SSIS came across data truncation. Okay, yeah. So don't forget now. It's important to remember that Data Factory or data flows, as opposed to SSIS, is a very different engine. Data Factory data flows is built purely on Spark Databricks. By the way, it's a good question. Let me quick show you all before we go. I still have my browser shared. The Data Factory is going to be spinning up and using Databricks behind the scenes. You don't pay extra for that Databricks. That's part of your data flow bill that you get. The hourly cost of data flow includes the compute. If you're using Synapse, so over here on Synapse Analytics, this is all available to you as well, all of the same capabilities. So all of the inline data sets, the new source types are all on here as well. For some reason XML is not showing on here. I gotta look at that. But it's all available to you here in Synapse. When you run this in Synapse, you execute this, it just executes on Synapse Spark instead. So one of the interesting things about that, by the way, when you're in Synapse Spark, is you can also see the execution log for the Spark execution of your data flows. So if you go into the monitor and you look at your Spark applications, you will be able to see the data flow debug and the data flow executions. If you really want to get that detail, I know sometimes I get questions from users and customers who want to see that level of detail. You can in Synapse if you're interested. So going backwards here, any way to dynamically read select sheet names? Excel sheets often have changing names. Interesting question. So right now you're sort of hard selecting that. I'll take a look at what we can do with that, Matthew. I'm not sure of that one right now. Let me make a note for myself on that. Okay, so thank you. Awesome, thanks. Yeah, you're welcome. Anytime. Teams are about to receive a Databricks instance specifically for the PDF use case. But okay, got it. Maybe I should not be reading back up. Maybe I should be reading top down. CDM sync. Yep. No PDF yet. PDF files. Use a source. No PDF. That's a good request though. Keep those coming. We can always add more format connectors as well. Great demo. For Xlsx, must the sheet be in a table format or can it be out of table format? See if I understand correctly. So when you define the data in the sheets, I'll show you how you define it. Maybe this will answer your question. If not, we can always take it offline to get more detailed on it. So let me go over to this one here. So this definition in the connection information for the data set, you can set ranges, but you set a sheet name. Oh, this is editable, by the way. This kind of answers the question we had earlier. So you can add dynamic content, so you can parameterize the sheet name. So I'm just kind of thinking out loud on that question about the dynamic sheet name. I think it's a great question. I gotta do some demos and some playing with that a little bit to see if we need to make that a little bit better. That's the experience today for this first cut of Xlsx, but some good feedback. But you can set ranges in there, so you can set cell ranges for what you'd want to the data you'd want to bring back in that sheet. Oops, not exclamation. Me too. I've already had the question before too of being able to provide function support as well, so that you could have functions against your or lookups against your data from here. But the better way to do that today would be just to bring all the data into data flow so we can data frame it, and then we'll do the lookups within the data transformation and data flow. Let's see, back to the questions. Logic apps requires table, drives me nuts. So glad that doesn't require. Okay, let me look at that in further detail after the demo here. Let's see, let me go back. I think Dan probably answered everything else. If you have any other questions on these, go ahead and post the questions on the video after it is uploaded, and I check the YouTube channel every day, so I'll be happy to get more answers for you all if I need to bring in engineering for any of those. But I appreciate everybody's time today. It was great to catch up with everybody and to see everybody again. And we'll post the video and we'll post the live stream for next month as well. So if there's anything else you'd like to see for demos on Data Factory and training on it, just let me know, and we'll see if we can get that scheduled. Thanks again, everybody.